This video is going to discuss sets. So set is another interface that extends the collection interface. So it's another type of collection, another type of data structure. And set describes a collection that the key things is that it does not allow any duplicates. So sets can only be used for unique elements. So if you're going to have an element repeated within your collection, then you should definitely not use a set. Okay. Now, we typically, in a mathematical sense, think of sets as being unordered, but sets in Java may or may not be ordered. And we'll talk about one that is and one that isn't. But the key thing is here is that it's a collection that does not allow duplicates. The first class we're going to talk about that implements the set interface is hash set, and hash set implements the set interface behind the scenes with a hash table. A hash table, we're not going to go into hashing in detail, but a hash table is basically just a way to index objects by some key. And we are going to talk about maps in the next video, but I don't want that to be the focus of this video because you don't really need to understand that to understand sets. We'll talk about hash tables and maps in a moment in the next video. But for now, just think about a hash table as being like a table, like it says, where you have some sort of key here and some sort of value. And so you have pairs of keys and values. The key that's used behind the scenes for hash set is an object's hash code. Now there is a method, hash code, that every object has because it's inherited from the capital O object class. And that hash code is meant to return a unique value that describes that object. That is the code that is used behind the scenes to implement hash set. So again, if this kind of doesn't quite make sense yet, that's okay. Don't worry about it. I just put it here so that you have a little bit of information about what a hash set is and why this word hash is even in there. It's in there because behind the scenes, this isn't implemented with an array or linked nodes. It's implemented with a hash table, which hash tables in general are very fast, and that's part of what makes hash set a very efficient class to use if it suits your purposes. Anyhow, this is also what allows the class to prevent duplicates, because if there already is an object in your table with the key, the same key as when you're trying to add, it won't let you add another value at that spot. So there's only one object per key. Okay. Hash sets does not guarantee any order. So there's no ordering here. So whatever order you add things into your hash set, they're not guaranteed to remain in that order. When you get an iterator out of your hash set, you have no idea what the order is going to be. Okay. So you can't make any assumptions about ordering. So hash set does not maintain any sort of ordering. Another class that implements the set interface is treeset. Now, treeset does have an ordering. It's a sorted set. So it's a set. It doesn't allow duplicates. Behind the scenes, it uses what's called a red-black tree to implement this class. But the key thing about treeset is that, again, the objects are going to be sorted. Now, they're going to be sorted using the natural ordering of your class. So whatever elements are being held in that treeset, it's going to use the natural ordering. That means it uses that compare to. But you can create a treeset using a different ordering by just sending in a comparator to the constructor, and then you can use that ordering instead of the natural ordering. So the default is the natural ordering, but you can change that by sending in a comparator. Now, one thing to be careful about is that we've said that sets don't allow duplicate values. Well, for a tree set, duplicate values are determined by that compare to method, or if we're using a comparator, by that compare method. And that means if two elements, if you compare them and you get a 0 back, they're considered a duplicate, even though the rest of the characteristics might not be a duplicate. And I'll show you an example of what I mean by that when we take a look at the code. So let's do that now. Let's take a look at the code. So we're going to use the same data file, only we're going to test out some sets. So I'm going to start out the same here. Let me actually just comment out some of the things we're not doing yet. So this is my set tester file, and I'm going to start the same way I did before. I'm just going to fill up that set. So here I'm declaring a set, that's my interface that holds business objects, and I'm going to initialize it first as a hash set. And again, remember, for generics on the right hand side here, you can either include that type or not, but you definitely have to include those caret brackets. Okay, so I'm just going to fill up my set. Let's go down to my fill set method. It looks pretty much the same. The only difference here is instead of ignoring the return value from the add method when I add something to my set, I am capturing it in a local variable, and then I'm going to print out if that add fails. And we're going to do that. I'm going to show you why we're doing that in a moment. But otherwise, I'm just creating the business and adding it to the set. So that's very similar to what I just did for the list. So let's go ahead and run that with hash set. Filling up our set took about the same amount of time. So it's comparable to building our linked list and building our array list. Now let's take a look at our data file here. And what I'm going to do is I'm just going to add a duplicate. So I'm just going to take one of these rows and I'm going to duplicate it. So there's now a duplicate in here. I'm just going to save that. I'm going to run this file again. And now you're going to see that it failed to add that business. So if you try to add a duplicate to your set, it will fail. It will return a false from the add method. It won't let you add a duplicate. Okay. Now let's try the same thing with tree set. So again, it failed to add that business, then build the tree set, comparable time. And now let's build a tree set, but instead of using the natural ordering of a business, I actually wrote a little comparator. So again, we have our business class here. I modified the natural ordering to just order by ID. So this is our natural ordering. It just orders by ID, right? And now I wrote a comparator that orders by owner's name. Oh, shoot, let me update this. Sorry, we're going to do this in a moment, the rest of this. Okay, so the comparator here just compares by owner's name. So again, I have my class that implements the comparator interface, comparing two business objects. The compare method then takes in two business objects. So again, my implement comparator with generic specifying comparator business. That means my two parameter types are business, and then I'm just going to compare the two owners' names. So this would be a way to sort or to compare by owner's name. So if I want to create a tree set, which would be a set collection that doesn't allow duplicates, but that orders things instead of by their natural ordering, which is by ID, it orders things by, in this case, owner's name, I can just pass in to the tree set constructor an instance of my comparator, like this. So I can just pass in my owner name comparator, and now that's how it will be sorted. Okay, so let's now build the tree set. Oh, and look at a bunch of businesses have been failed to be added. Now, why is that? Well, that is because what I was just referring to a minute ago, that what defines a duplicate is now however our ordering is defined, which is now defined by this compare method. So if I have two businesses with the same owner's name, those are going to be considered a duplicate. So I'm not going to be able to add them both to my tree set. Okay, so you have to be careful when you use a comparator. Now, maybe that's what you want. Maybe you want a set of businesses that are unique by owner, right? So you want all the businesses in San Francisco, but only one business per owner. If that was the case, then this is exactly what you do. You'd create this comparator that sorts by owner name, that compares by owner name, and then you can use that to build your tree set. But if that's not what you want, if you want all the businesses and you just want them ordered by owner name, then you have to use a different comparator. So I'm going to write a second comparator. I'll call it owner name ID comparator. And again, it's still just going to implement my comparator interface. But now I'm going to compare my two businesses first by name. But if those names are equal, then I'll compare them by ID. So if the two names are equal, then I'm going to return the comparison of the ID. But if they're not equal, if they're different names, then I'm going to return the ordering of their names. Okay, so this should mean that I shouldn't have any duplicates in my list because all the IDs I know are unique. Okay, and then I'm just going to declare another comparator that I can use outside of this class. So this will be my owner name ID comparator, like that. Okay, and now in my set tester, now that's the comparator I can use, and this should allow me to build my tree set ordered, but with the ordering specified by owner name and then ID. And this should just fail to add that one file now, because that one record rather, because we added that one duplicate, right? So if it did fail to add that, otherwise the building of the tree set took about the same amount of time. Okay, so there's an example. Let me get rid of this duplicate. There's an example of creating three different sets, a hash set, a tree set, and a tree set using a different ordering. And they all took about the comparable amount of time. So now let's do an iterator. So let's try to find a particular business. So what I've done is I've again just created a business ID. And this one is the first one on the list. Actually, first let's put this back to hash set to start with. Got hash set first. Okay. And then here I have my find business iterator method. So I'm just like I did with the list, I'm sending in a set and I'm just getting that iterator. The rest of the code is actually exactly the same. I just get the iterator, I iterate through. If the ID equals the one I'm looking for, I return that business. So let's run this now with hash set. Takes about the same amount of time as it did with our lists. Now so that was 32 milliseconds. Let me change, this was the first ID on the list. Let's just pick a different ID. Let's pick the last ID on the list. And you'll notice that the hash set operates a lot quicker. So here, again, the ordering, you're not guaranteed that order is the same as your insertion order. The order is not guaranteed. So with a list, right, if I know that I'm trying to find the first thing on my list or something early on my list that I know I added early on, I know it's going to be pretty quick. But if I'm trying to find something in the middle or at the end, it might take longer. With a hash set, there's no guarantee of that. There's no ordering that's guaranteed, right? That's the definition of a hash set. So you don't know what order things are stored in behind the scenes. Okay. Let's try it with tree set. And again, tree set, this is going to use the natural ordering. So this is going to be the ordering by ID. And again, there you can see, so now it takes a long time to find that one, or 34 milliseconds, relatively long, compared to if we try to find one at the beginning, it's going to be quicker because again, these are being ordered by ID, right? So now we do know something about the order. We know that behind the scenes in a tree set, they're being ordered by ID. And of course, we could also do this with a tree set of the owner name. I don't have the owner names listed here, so it's not going to really tell us anything. But so there's an example of finding an element within your collection. Okay. Now, the one thing that, so now let's do a processing. Sorry, ahead of myself there. Let's do a processing. So here again, we have a similar method to process. So we're processing all our businesses where we send in our set. This is the same, except the only thing I changed is I added some printouts here. So we're going to print out the first couple records that are processed so that you can see what I mean about the ordering. Okay, so otherwise this processing method is the same as it was in the list class. I just use an iterator. I get the business. If the business is in California, I process it. And again, this is just then I don't want to print out all 150 whatever thousand businesses. So I just want to print out the first 5 or 10. So I'm going to start printing out the first, let's say 5. Okay, so let's go ahead and do this with hash set. Yep, I've got a hash set in there. So let's do this with hash set. So the processing took 42 seconds. That included the print. So that's comparable to what I did for the list. And you can see that there's, no guarantees about the order here, right? I don't know what this ordering is. There's no guarantee about the order returned from the iterator. Okay. And in fact, if you take a look at the hash set, at the hash set API, and you go to the iterator method, they are returned in no particular order. Okay, so you just don't know what order it's going to be. Okay, now let's go and use a tree set. And remember, the regular tree set uses the natural ordering, so the compare to method. So this should order our processing these in the order of ID. And you can see that they are being processed in the order of ID. So the first one processed is that ID, and you can see the IDs are increasing here. Okay, so that is processing them in order of ID. Let's say we wanted to process them, we wanted to keep them ordered by their owner's name followed by their ID. We can send that comparator into our tree set. And then that's the order that they'll be processed in. So you can see here the business owner's name. This is, a hash 10. Then the owner name starts with a 03, starts with a 1, starts with a 1. So you can see that these are sorted by owner name. And maybe if we print out a few more, that's a little easier to see the ordering by the owner's name. Okay, so you can see these are alphabetized by owner name. Okay, so again, the processing for a hash set, it's comparable in time to using a list, but we don't know any order. For tree set, there is going to be an order, and the ordering depends on whether you use the natural ordering or whether you use a different comparator. Okay, so let's put this back to hash set. And then the last thing I want to show you, which this is one thing that sets are really excellent at, is determining whether something is in your collection. So let me jump back actually to the list tester for a moment, because I added one test here. I added a test where we created a business that's not on the list. So I just created this business with a bunch of missing data plus an ID not on the list. And we're going to determine how long it takes for an array list to figure out that that business is not on the list. And of course, you could search for any element. This is just the idea of trying to figure out whether something is on the list. And I just want to pick something that isn't in the collection to force it to look through the whole collection. So for our array list, that took 30 milliseconds. For our linked list, took 19. So, somewhat comparable there. So now let's go over to our set. And actually, before we do that, I'll just show you. So all I'm doing is invoking the contains method. So this isn't a method I wrote. This is just invoking the contains method from on that list object directly. And I'm going to do the same thing here on my set directly. I'm just going to invoke the contains method to determine if this business is in my hash set. I've got that set back to hash set. And you will see that it happens in, drum roll, constant time, 0 milliseconds. Let me remove these printouts here. Okay, so 0 milliseconds. Let's change that to tree set. Again, determining whether that business is in the collection, 0 milliseconds. And let's use our tree set with our comparator. Again, 0 milliseconds. So this is all because of how things are stored behind the scenes. We are able to get this constant time efficiency for determining if something's in our collection. So if that's what you need to do, like let's say you're reading a bunch of stuff in from a database, and then let's say you're reading in a bunch of user account information, and then you have a whole list of user accounts where you're just checking, hey, are they already on my list? Are they already on my list? Are they already on my list? Set is a great thing to do, because each one of those, hey, is it on my list? Hey, is it on my list? Hey, is it on my list? Checks happens in constant time. Whereas with a list, it happens in linear time. You have to basically iterate the whole list to determine that. With a set, it's constant time. And that all has to do with how it's implemented behind the scenes. Okay, so that's one thing that is much, much quicker with a set versus with a list. Okay, lots of other things are kind of comparable, and then between hash set and tree set, there are some differences as well, but that's an example of using sets. Okay, so in general, when are sets good to use? Well, the key thing here is duplicates. If your collection has to have duplicates in it, then you absolutely should not use a set. But otherwise, sets can be really good at kind of doing the same things that lists can do, applying an action across everything in your collection or across some elements that meet your criteria. But they're actually better than a list for determining if an element is in your set. So again, if that's the action your program is taking, set is a great thing to do. They're kind of also not as good as finding a specific object based on that characteristic. So that same thing we were doing where we're finding a business with a specific ID, and this should be a little different there. Sorry, I'll update that. That is basically, it's comparable. It's comparable doing that to a list. So that maybe isn't as efficient. Although with a tree set, if the ID is what the set is sorted on, then that will be a little bit more efficient. So if we go back here and let's use a tree set, which remember is sorting on ID, and then we're looking to find a business with a particular ID, that should be a little bit quicker. Depending on what the ID is, depending on how we sort things. Okay, so you might be able to get some efficiency there. But in general, sets and lists, this really isn't what they're made for. Okay, they're more made for treating things as a whole collection, doing things to everything in the collection, or doing things to the elements that meet a certain characteristic within that collection. Okay. Now, in terms of comparing hash set and tree set, hash set is quicker behind the scenes, but it doesn't provide any ordering. So if you don't care about ordering, you definitely want to use hash set over tree set. If you do care about ordering, you definitely want to use tree set over hash set. Okay, so basically, even though hash set's more efficient, if you need ordering, it doesn't matter that it's more efficient because it doesn't give you what you need. So it basically comes down to ordering whether you'd use one of these two classes. Now, one just last little cautionary note about duplicates. You can't add a duplicate element to a set. We just saw an example of that. We basically copied a business. We had two records that were the same in our file, tried to read them in, and it failed on adding those. However, what it would be allowed to do would be to build your set and then go in there and modify one of our elements to change it into a duplicate. There's nothing to prevent you from doing that. So technically that is allowed. And so you just need to be a little bit aware and a little bit careful of that. So let's say, for example, we had a set of student objects and we had two elements in there, S1, and let's say a student is only defined by their name. So S1 student is Jane Doe and S2 student is Mike Smith. If we can't add a third student, S3, Jane Doe. That would fail, right? Because they'd say, hey, Jane Doe's already in this set. You can't add S3. But what I could do is I could get this S1 object and I could change the name to be Mike Smith. And then essentially I now have two Mike Smiths in my set. And that would be allowed. The set won't prevent you from doing that. So you have to be a little bit careful about that. One way to totally prevent that from happening is to use an immutable class. So you could make your student class immutable, and then basically there are no setters. And there are other things you have to do too, which we'll talk about in the future in another set of videos. But if you had an immutable class, then this prevents this, and you're guaranteed that your set will never have any duplicates of any kind. But if your class is not immutable, as most classes are not immutable, most classes do have setters, and they have the ability to change information about an object, it is possible that a set could be improperly modified in this way. So just something to be aware of, that this is possible. Okay, but otherwise, that is an overview of sets and two classes that implement the set interface. And next up, we're going to talk about queues and decks.